And it's hammer time. So let's start with the head of the hammer. So we have this brass piece of scrap that I found, and it has a pretty good sized bored out hole. So I'm gonna go ahead and use that. It's a very small, thin counter bore at the very end. So we'll just use that when we press our piece in, it'll just stop up against there inside the hole. So I'm gonna go ahead and take my snap gauge, and we're gonna mic the inside of the hole here, get a size, because we're gonna go for a press fit. So as you can see, got the snap gauge in there, and I'm just gonna roll it out nice and straight. And then I'll take my 0 to 1 mics. I already have them pretty close. And I'll go ahead, measure down to the thousandth of an inch. Okay, got it there. And we take a look, we're looking at one under 900 thousandths, so 899 thousandths is the size of that hole. And I think it shifted on me slightly. It's just a hair over 899 thousandths. So what we'll do is we could even make the turn this down to just a hair under 900 thousandths, and that would be a nice, just a little nub of it. Press it in there so that presses through mostly, but not quite, because we want the hammer to have a soft brass side for a while, and then they can start to use the edges later on as they chip away brass closer to that pressed in steel piece. And then we'll make the steel piece a little bit longer than the brass piece, so it looks like a normal hammer. We'll drill through the middle, and then we'll be attaching a handle later on, and I'll show you that process. Now the other thing we're gonna do, we're gonna take our 1 to 2 mic, we're gonna mic the outside of this piece. Let's go ahead and do that. So look at we have a hole through this piece, so I can kind of line it up pretty center. Okay, that feels pretty good. And I'm looking at, but there you go, 1 and 840. And so I'll chuck up this piece up in the lathe, grab it here, turn this down, turn the front nub of it, maybe 3/8 or ½ inch of it down to that 899 or 900 or just under. And then the other half, whichever length I determine I want, that'll be turned down to the 1 and 840 to match with this. So it looks pretty seamless and same outside diameter. So let's get started. Touch the tip of the tool to the fully faced material and let it lightly drag across. And you may not be able to pick it up on video, but there is a slight mark right there. Should be able to see that right there. Okay, so now the tool is zeroed out at the front of the part. I'll come over here, I'll zero out my x-axis, if you will, if you want to call it a cross Y, either way. Now we're going to feed in a little bit more than 1 3/8. I want my hammer head to be 2 inches long. So I'll start cranking this handle, and as I crank it, it's going to be 1 inch. 1 and 100 thousandths, 1 200 thousandths. We're going for 1 3/8, 1 75. But we're gonna face it anyways, so we're gonna go to inches per 100, just to be sure. And now that that's that, we can actually kick on the lathe, and I'll feed in the cross feed, and I'll just touch it, just a hair. I'll go ahead and zero that out. So now, when I crank it back, I gotta start turning it down. That'll go down to 0, and that's when I know I'm done. As that's counting down, we'll kick our feed back off. 7 thousandths to go. A little too far. Well, that's okay for this piece. I'll keep feeding more. And for the final cut, I like to use some oil on it. Maybe sometimes get you a nicer finish, so let's see how it does. I'm only taking 10 thousandths as well. And this should take us down to our 841 and 840. Same OD as this. And then I just have to do this part, which this is about a 1/2 inch deep, so I'm just going to do a 7/16. Turn it down on the end, press it into there, and that'll be the hammerhead. Finish is looking pretty good so far. I actually am taking this out a little further than I initially had it. This part of it does have to press into this, the rest of it has to take up the other length. Feed is fast, so that's fine. That's plenty. You can take a little bit more in certain cases, other cases you can't. The air compressor seems like it runs forever between when it's on a cycle. Now that it's quiet, you can hear me. So, we're making the handle. We got a piece of 3/4 stainless. Damn, that's still hot. Just drilling through made this pretty hot. And I'll make the handle about, I don't know, 6 inches long, sticking out the bottom of the hammerhead. What we're gonna do is, I've already drilled the end. I'm gonna tap it with the 3/8 tap, plenty of fluid, and that way I can drill a hole through the middle of the hammerhead and have a little counter bore near the top, and then I can have a 3/8 bolt attach the handle to the hammerhead, but also this OD can be a nice, I can turn it down a little bit if I want, and that can be a nice press fit through that main hole, through the hammerhead, and then also bolt it so the handle does not come loose over time, because over time as hammers get old that will happen. So if we can avoid that, that is the plan. Smoke you see is just the oil being burned up the cutting fluid. Turn out the nice finish is taking 40 pounds at a time. Put the center in with the drum tap hole so that the piece won't be shattering real bad. Coming out pretty good. Project hammer is almost done. So I have, with a 5/8 end mill, milled down but not all the way completely through, because it's going to go up against the shoulder there. And what's going to go up against the shoulder? This stainless steel shaft, which will be the handle. And I have turned down 1.5 inches length of it down to 5/8. And I will press it into this hole. And the end of it, which I have drilled and tapped for 3/8, will butt up against that shoulder there. And there's a 3/8 hole, through hole, so I can bolt the end of my handle to the other side of my hammerhead. Now all I gotta do is swap out this 5/8 end mill for a 3/4 end mill, mill up nice flat, straight across, flip it over, do a nice flat on the other side. And then on the other side where the 3/8 bolt head is gonna go, maybe go to a 7/8 end mill, so that way you can actually get a socket onto this bolt head once I'm ready to tighten it up. But unfortunately, something is up with the whole thread in the mill, so we actually have to loosen it by hand from the top. This is the top end of that threaded piece that picks up your collet here. So, and we lost the power feed a while ago on the digital readouts. So it's a true manual machine here. $3/4 ml, because the handle of our hammer will be 3/4 in diameter, and let's see if across it's about 3/4. May have to feed the table up another 10 or 15 thousandths to get that full 3/4 width across. I'm looking at yeah, that's it. It's about 3/4. I'll take it. Okay, so now that that's done, I'm gonna deburr the edges here, and then we'll flip this over. And we'll have to try to grab it such that the bottom is perfectly straight up top. I may just, with the bottom being a 3/8 hole, I may put something in the drill truck that's 3/8, like a drill bit, and just stick it in the 3/8 hole side. That way we can line it up pretty vertically straight. Okay, we have it flipped around to the top side. Like I said, I put the drill truck up in the quill with a 3/8 drill bit, and I rotated my hammerhead until I could get it close enough straight up and down, and then I loosened this and I fed the quill down so that the 3/8 drill bit would go in the hole and center up the hammerhead vertically. You know, I had to bump it over slightly left or right, and then I had to crank the table in and out accordingly so that the drill bit would fall nicely right into the hole, my 3/8 hole, and then I knew that I'd be centered up, and I could take this 7/8 end mill and just run back across, going deeper and deeper each time. As you can see, we've made some good progress. I'm trying to get it so that the bolt head will sit at least flush with the top of the hammerhead or lower. So as you can see, still got a little bit of ways to go, but progress.